Hello all, hope you are doing good. This is Mani and I'm back with another video. In this video, we will discuss about what is the skill set required for data engineers in 2023. First things first, thanks for 100 subscribers and this means a lot to me. More content is coming and you know what to do. Before we jump onto the actual video, I would recommend you to go through what is data engineering and what is a typical data pipeline. Both of these videos are on the channel, so please check them out. Now let's jump onto the video. As data engineers, we deal with a lot of data on a day-to-day basis. We build processes through code to bring the data from different sources and load it into our data warehouse and perform operations. So more or less the data engineering is about data and little bit of software engineering. So we borrow a lot of parallels from software engineering and we need our data skills to work with the data. The skill sets that are required for the data engineers can be broken down into data and software engineering skills. Now let's jump on to the next section. SQL. SQL is the fundamental skill that is required by any data professional, be it data engineers, data analysts, machine learning engineers, anyone who works with data a lot, right? So what is SQL? SQL is structured query language. It is the language of any relational database which stores the data in tabular format and in tables will use SQL as the language to query and retrieve the data. SQL offers a very simple enough interface where we can give some queries to the database engine and we will get back the results in a tabular format. This simplicity allowed many professionals across many levels to just retrieve the data from a database or any system that would allow the SQL queries to run on. So naturally, this skill is very popular in data engineering world as well. When we deal with lot of data that is in tabular format, we will use SQL a lot. As we spoke, right? SQL offers a simple enough interface where we can query the data. So those queries look something like this. First is like use database name. That means if you have a specific database in your database under your database, you can use that particular database to run your queries on. Again, show the tables within the database specified within the first command. The second command shows the tables within the database that is specified in the first command. Next up is we are selecting all the columns that is present in table name. So these are a few queries that you can see here with there are some conditions here. There is a way to get the distinct values out. So these are very helpful in our line of work. So we use SQL a lot on a daily basis. This is not just only one use case where we use SQL. We use SQL for data modeling. That means if you want to specify a data in a certain format, either it is in a staging layer or in an aggregation layer under data warehouse architecture, we can use SQL for that. We can also use the same queries to clean the data for large scale analytics as well, to create specialized data sets, to run deep analytics work on the data that is either present in a raw layer or on a staging layer within the database. This is about SQL. We have additional skills on under the data section that I have mentioned. So one is data modeling and data warehousing. These are necessary, but we use them on a day-to-day basis, but not as prevalent as SQL when you are a developer or an analyst on the team. But if you are a lead or an architect, you use data modeling and data warehousing concepts where, pretty much more than any engineer. The next skill here is Python. Python is a programming language that is ubiquitous in data world, be it data engineering, AI, ML, or data science. We use Python or libraries that are written in Python a lot. In data engineering processes, we bring in data from different sources every single day, right? So these sources can vary from an API or a file server or a database or streaming events, so on and so forth. If you want to integrate data from all these sources into our data warehouse, we need a framework of sorts, and we can't handle 10 different languages or 20 different types of processes that are not consistent, right? We need one single language that can help us, achieve that goal. Python has rich libraries to interact with any of the data sources that we have. It will cover most of the use cases that we have in the engineering world, as well as Python offers tools like pandas to do exploratory data analysis on the incoming raw data. So pandas is a data frame based library where we can see or visualize the data in tabular format with rows and columns. So what Python offers is a simple enough scripting way of writing code, and we can use that functions or libraries to build our framework to our needs and then scale it accordingly. Not just that, we can also use just the Python language to clean the data, to transform the data, and to load the data into staging layer from the raw layer. So these are the tasks we can perform with Python as well. We have distributed computing framework like Spark, which uses Python wrapper, where we can write Python code that uses Spark libraries underneath. Next important skill is data warehouse. The central part of any data engineering process is a data warehouse. Data warehouse is where we store the data, where we analyze and we build data sets and serve the data at scale to multiple stakeholders. When the data is huge and growing, we can't fit all the data in a single node machine or single machine, right? So either we use a cloud based data storage systems, or we can use a Hadoop based cluster environment where we can add more nodes as we want storage or processing, right? So Hadoop uh, clusters or Hadoop environment was very prevalent or very ubiquitous in the data world uh, few years ago. Right now we are seeing more and more of cloud based offerings like Snowflake, BigQuery, or even Databricks, that is combined with cloud based storages like AWS S3 or Azure Blob Storage. So these are very good options. Having knowledge on Hadoop ecosystem, the important components in the Hadoop system like HDFS, MapReduce, and Hive, and so on and so forth. These components will help us understand how the distributed computing is happening under the hood, and how we can optimize the processes that we are running on the Hadoop cluster. So most of the principles that we used in Hadoop are seen in modern data warehouses or processing engines like Spark. Spark is an open source data processing engine where we can interact with the data using either the Spark APIs with Python or Scala, or we can just write plain SQL to even interact with the data within the uh, Spark environment, right? So, having knowledge on the internals of Spark or any data warehouse like Snowflake or BigQuery will help us understand how our application is running under load in different scenarios and how we can improve those particular scenarios. Understanding data warehouses or understanding cloud data warehouses and processing engines like Spark takes us a long way in our data engineering journey. This is one of the important skill set to learn as a data engineer. So these are the three important skill sets. First one is SQL, second one is a programming language, preferably Python. The third one is knowledge on data warehousing tools or cloud data warehousing tools like BigQuery, Snowflake, or Spark. So I am biased towards Spark because that is what I use on a day-to-day basis along with Azure. Moreover, Spark is very ubiquitous in the enterprises where we have Spark that is offered through Databricks. with a notebook based interface, or we can use the open source Spark version itself to write the code in Python files and then execute on the cluster. So it is up to the infrastructure, how it is set up within the particular organization, and how they are running those applications. There are additional skill sets as well that as data engineers we need to know. The first one is Git. A Git repository is where we store the code for our tables or our processes, ingestion frameworks, all the details, the data and the metadata about these can be stored in a Git repository. So knowing basics of Git, how the Git works, how we clone the repository, how we make the changes, how we publish them, how do we make a pull request, all of these will help us, understanding the processes well. And next up is learning the important cloud services that are essential for data engineers, right? One is cloud data storage and any cloud, as I've mentioned, any cloud data warehouses. The next up is any um, serverless tools, like in AWS we have Athena, where we can write queries on the objects or data that is stored in S3, and even tools like Synapse in Azure world, where we can write the data into the Synapse data warehouse and query the data directly using SQL. So these will help us understand how the modern data warehousing or data engineering process are set up and currently in motion. The last but not least is understanding about one orchestration tool like Airflow or Azure Data Factory, Apache NiFi, whatever particular organization use or your particular organization is using at the moment. The most like popular one is Apache Airflow, where we use Python code to connect different services and run trigger different jobs and even retry the jobs when they fail, and all of these functionality are present in Apache Airflow right out of the box. Knowing that would help us to understand how the like data engineering jobs are scheduled, run, and how we are getting the data into our data warehouse. So the best way to learn any orchestration tool, in my opinion, is on the job. We can know the basics on how to create a job, how to create a DAG, and how we are triggering the pipeline. All of these are fine. Knowing the basics is fine. Once you know the basics, a work environment gives you the clear understanding of how a job is scheduled and what are the parameters, what are the other jobs that are parallelly running within this particular environment, and how do we optimize the bandwidth that we have on the particular cluster or on our particular environment to get the most out of our particular resources is how we learn on the go. This is true for every skill and more so for the orchestration tools or any operation tools within our stack. The operational tool here is Apache Airflow, right? So that being said, we are at our concluding section of the video. I hope you like this one. So if you have any doubts or comments on this particular video, let me know in the comment section. I would I'm happy to reply. Or if you are using an entirely different tech stack, please comment down or in the comment section. I would love to know about that as well. And see you in the next video.